Hey guys, Mr. Rubin here, and welcome to another session of Flip Learning. Alright, so today's topic is adding, subtracting algebraic fractions. Today we are aiming to, by the end of today's lesson, is to solve algebraic fractions problems by converting denominators. And what will that look like? Well, we'll find out a bit more in detail. Alright, so first of all, an algebraic fraction is basically a fraction that has algebraic terms in it. So we've got both numerals and pronumerals. So that means that the numerals are numbers, the pronumerals are the letters. Now the letters represent unknown numbers, okay? So, to summarize that, algebraic fractions are a fraction that could include algebraic expressions in the numerator or denominator. So the numerator at the top or the denominator at the bottom. So here we go, here's one here. 2 times x divided by 5, or 3 over 7a plus 4, or 2x over 7a. Now excuse my dodgy writing. Okay, so there you go, there's 3 different algebraic fractions. Now, let's have a crack at, let's get straight into it actually, and have a go at adding some fractions together here in this example. So first of all, LCD is a great acronym and it stands for lowest common denominator. And without a lowest common denominator, we can't actually add or subtract fractions. So here we go. We've got 2 algebraic fractions here, x over 3 and x over 4, and we are going to try and add them. Now, let's look at the denominators. What is different here about these denominators? Well, for starters, they're both different numbers. That's what's different. So, we need these numbers to be the same to complete this addition, okay? If these denominators are not the same, we cannot add them together, okay? If this were a subtraction and these weren't the same, we couldn't subtract them either, okay? These two need to be the same. So, to find the lowest common denominator, one way is to write out the multiples, right, of both of those denominators. So we've got 3 and 4. So let's write out the multiples of 3, just to a certain point. So let's go, we've got 3, 6, 9, 12, 15. Alright, I think that's far enough. Now let's go 4, 4, 8, 12, 16. And we go until we find a common one. Now I've already found one. And the lowest common number here, or lowest common denominator in this case, or lowest common multiple, is 12. So, coincidentally, to get 12, that means we have to times each side by the opposing denominator. What that means is we're timesing the 3 over here by the 4 then to get 12. Now, what we do to the bottom, we also need to do the top, so we will also times the top by the 4. Now, our x over 4, what does 4 times something must equal 12? You've got it, 4 times 3 equals 12. What we do to the bottom, we need to do the top. Okay, so if I rewrite this, okay, I might have to do it next to it. So if I rewrite it, now I'm just going to try and get rid of this equal sign because we're not, alright, can't do it, just ignore it. So I'll rewrite it over here. So x times 4, what's this going to be? You got it, 4x. Over, what's 3 times 4? 4, 8, 12. Well, we already knew that one, didn't we? Plus, alright, what is x times 3? That would give us 3x. And what is 4 times 3? Well, we know that. That's 12. Okay. Now, we're at a point where we can solve it. The denominators, we do not add those together. They just stay the same. If we were multiplying them together, then we would go 12 times 12. But because we're adding them, it just stays as 12. So whatever our answer is, now, sorry to be all over the screen here, but I'll put a little equal sign there. And our answer is going to be whatever it is will be over 12, we know that. So we just need to solve the top. Okay, what is 4x plus 3x. Now, a way to look at it is to, if I draw a line out around all of these, so simply just solve what I've put into that bubble. So we've got 4x plus 3, 4, 5, 6, 7 x. And that is our answer, 7x over 12. Alright, let's have a crack at another example. Here we go, 4a over 3 plus 2a over 5. What's the first step again? You've got it, find the lowest common denominator. Now, we can write out a list of multiples if we want. For example, we go 3, 6, 9, 12, 15. However, without thinking too much about it, I bet you've already guessed that the lowest common denominator will be 15. Now, a simple way of going about that would simply just be by timesing each one by each other, and you know you're always going to get the common denominator that way. However, in some cases, the number will be less than what that might be. So, but in this case it's not. So let's start with 3 times 5. We need to do the same to the bottom. What do we do to the top? So it'll be 4a times 5 up there. Now over here we're timesing this side by 3. So 5 times 3 and 2a times 3. Alright, let's rewrite all of this underneath it with the appropriate answers. So what is 4a times 5? Dodgy, 20. 20a over 3 times 5, you've got it, 15 plus. Now, we already know that our denominator is going to be 15, so I'll put it in there. Now, else we need to solve is this here, which is 2a times 3. 2 times 3 is 6, and the a just stays the same, so I've got 6a. Now, what does this equal? Well, remember, we don't do anything, we don't need to add these two together, they stay the same, right? Another way to look at this is, and I'll do it over here, is that you can actually just write this addition as though it were all above the 1 plus 6a, alright? So you could represent it either of these two ways, this way or this way, alright? So let's look at this. Anyways, 20a plus 6a. You've got it, 26a. Well done, guys. Okay, let's look at the next example. Here we have subtraction. Now, lowest common denominator. I'm going to let you guess this one straight away. So we've got them here. So we've got a 5 and a 10. What do we think it might be? Well, 2 5s make 10. And that would mean that that would be our lowest common denominator. So let's start with 5 times 2 and 6k times 2. So we don't need to do anything else to this other side here as the 3k over 10 because we are already going to get the same common denominator. So let's rewrite this underneath. 2k times 2, 6k, sorry. 6k times 2, what does that equal? 12k over 5 times 2, which is 10, minus 3k over 10. Okay. Now, what I put in this bubble, that's all we need to work with, okay, to solve this one. Our final answer is going to be over 10. Okay, remember we don't need to subtract the denominator. We're just working with the numerators here. So, 12k minus 3k. 12 minus 3, what's that, 9? You've got it, 9k. There you go, 9, 10, 11, 12. That adds up, doesn't it? It's always good to check our answers, okay? Alright, how are we going so far? Alright, what I want you to do is now to pause this video and then have a go at answering this one, okay? Alright, well done. Now, I'm sure you've had a go at that, but what I'm going to do now is quickly show you how to solve it. So, our common denominator ended up being 18, alright? So we need to put everything over 18. So we've got 18 one side, 18 the other. Whoops, sorry, dodgy 18. How's about I try and rub that out and rewrite it quickly? And whatever it's going to equal will also be over 18 without knowing that we have to simplify, okay? So, 6 times something equals 18. 1 6 is 6, 2 6 is 12, 3 6 is 18. So what we're going to end up with is 3a, because we'll times that by 3 and times that by 3. And 9 times 2 equals 18, therefore we need to do the same to the top. So that will also be, there you go, 2b. So 3a minus 2b over 18. Well, that's our answer. Because a and b are not like terms, they cannot subtract from each other. Therefore, we just write them like that on top of the 18. Alright, there you go. Well done, guys. So just keep watching through this one. Go back and watch it as many times as you need to, and then have a go at completing some more questions. Hope you enjoyed this lesson, and please write in the comments below. Alright, have a great night, everyone. Cheers.